All right, so in this video, we're going to talk about how to solve absolute value inequalities. So let's take a look at something very, very simple. Let's take a look at the absolute value of x is less than or equal to 2. I'm going to draw a number line. Now, the boundary values are going to be -2 and +2. And because it's less than or equal to, we know they're both included. So what other numbers would actually make this inequality true? Well, certainly 0, 1, and -1. So it should be any number that is in this interval. So I can write this out in interval notation as -2, 2. Now, I would like to be able to write this out as two simpler inequalities. Well, one option could be that -2 is less than or equal to x, which is less than or equal to 2. Now, you know this is an and compound inequality, so you know I can rewrite this as x is greater than or equal to -2 and x is less than or equal to 2. Notice when I rewrite them in either of these forms, the absolute value bars go. All right, so let's do something similar with the absolute value of x is greater than 4. So again, I'm going to redraw a number line with 4 and -4. These are the boundary values. But because it's strictly greater than, these are not going to be solutions. So what would be a number that would make this inequality true? Well, 5 would certainly work. 6 would certainly work. And numbers bigger than 6. But are there any other types of numbers? Well, -5 and -6. So this region would work also. So keep in mind, I don't have to be a solution in both. I need to be a solution in one or the other. So this is going to be an or statement. So in interval notation, that's going to be -infinity to -4 or 4 to infinity. So I can rewrite this how? X is less than -4 or x is greater than 4. Now, let's compare. When we take a look at the absolute value of x is less than or equal to 2, one of them is just x is less than or equal to 2. The other one, we switch signs and we do the opposite. Think of it as like dividing by a -1, switching the inequality sign and making the 2 a -2. When we take a look at the absolute value of x is greater than 4, one of them is just x is greater than 4. The other one, switch the sign and take the opposite number. Again, think of it as like dividing by a -1. So, in general, if x is less than a, then, well, two ways to rewrite this. One is -a less than x, which is less than a, or I can rewrite it as x is greater than -a and x is less than a. If it's an or statement, then I could rewrite this as x is greater than a or x is less than -a. Okay, so now let's take a look at solving some absolute value inequalities and writing the final answer in interval notation. Okay, so again, the goal for this is to get rid of the absolute value bars. So you know now the absolute value bar is by itself and it's less than. So we know this is going to be an and statement. Right? One way I can do this is this. And then I can solve for x for all of this. Multiply by 2. I can subtract 9. And then divide by -4. Now remember, when you divide by a negative, you switch the inequality signs. So this is telling me that x is greater than 3/4 and x is less than 15/4. So I can draw some number lines for this. Okay. Now remember, it is an intersection, so it is where they are going to overlap. So again, that would be from 3/4 to 15/4, meaning any particular number that is in between that interval would actually be a solution. Okay. Okay. Now, there is another way that we can do this. So let me show you the alternative method for this as I scroll down. Now notice I rewrote the same exact problem. Now I can rewrite this as two separate inequalities. One would be this, and the other would be this. Okay, so let's start here. Multiply by 2, subtract the 9, and then divide by -4. X is greater than 3/4. Here I can multiply by 2, subtract the 9, and then divide by -4. And again, the exact same solution would apply here that we had up a minute ago with this. Okay, so let's solve the next inequality then. Again, I want to get the absolute value bars by themselves. So I'm going to subtract the 5. And divide by 3. Now, the absolute value bars are by themselves, and it's greater than or equal to, meaning this is an or statement. So I'm going to rewrite it as 2x plus 1 greater than or equal to 3, or 2x plus 1 is less than or equal to -3. Solve each inequality. Greater than or equal to 2. X is greater than or equal to 1. Okay. All right, so from there, then, I'm going to sketch these on a number line. Now, remember, it's an or statement. So let's do 1 first. Okay. Now I will do -2. Okay. Now, it's an or statement. But again, remember, I'm going to write this from smallest to largest. So it will go from what? -infinity to -2, union 1 to infinity. So any one of those numbers in either of those intervals would make this inequality a true statement. Okay. The last problem I want to take a look at is this one here. Again, I want to get the absolute value bars by themselves. I'm going to subtract the 5. And I want to divide both sides by a -2. Now remember, when you divide by a negative, you must switch the inequality sign. Now, the absolute value bars are by themselves on this step here. It's less than or equal to. That is an and statement. Okay, so again, I will show both methods. The first method would be this. Okay, add the 4. And divide by 3. Now, Again, I want to make sure this makes sense. Remember, that's telling me x is greater than or equal to negative 2/3. That's the first part. And the second part is x is less than or equal to 10/3. Now that certainly makes sense because where do they overlap? Between the 2/3 and the 10/3. There's my solution. So any number in that interval would make that inequality a true statement. Okay. All right, so your other option is when you get down to 3x minus 4 is less than or equal to 6. I can write this as 3x minus 4 less than or equal to 6. And, that's an and there, 3x minus 4 greater than or equal to negative 6. So add the 4 and divide by 3. For my other inequality, add 4. So again, looks exactly the same as what we have here, so I would write that in interval notation. And we're done here. Either one of these methods with an and problem will get you to the correct answer as long as your math is correct for it.